Hello and welcome. In this video, we will demonstrate the convolution operation using Python and TensorFlow. All the code will be run in the interactive Jupyter notebook. For the first example, we're going to use the pure mathematical notation. Here we have a one-dimensional convolution operation. You can use the following code to perform convolution between two arrays. As you can see, it's fairly easy to do with Python. We'll also verify Python's output using the convolution equation. And then, we'll manually execute the computation. As the kernel slides across the array, we can pad the array with zeros. This has an important effect in certain applications, so let's see how it works with an example. Notice the position of the dash. This is where we'll append a 0 to the array for convolution. We're also going to invert the filter x, otherwise we'd be performing an operation known as cross-correlation. For the first step with 0 padding, we'd have 2 times 0 plus 6 times 1, which equals 6. For the second step, we'd simply have 2 times 1 plus 6 times 2, which equals 14. The arrows represent the connection between the kernel and the input. Then it continues on for the third step, and the fourth step. For the fifth step, we're going to use a padded 0 on the other end of the array. So we'd have 2 times 4 plus 6 times 0, which is 8. So the final result of our convolution is the array containing 6, 14, 34, 34, and 8. We can verify this using NumPy. Sometimes you'd want to perform dimensionality reduction, in which case you'd want the resulting array to be smaller. In that case, you can perform the operation without padding the array with zeros. So let's take a look at that. Again, we'll invert our filter before starting. For the first step, we'd simply have 2 times 1 plus 6 times 2, which is 14. We'll slide the kernel across and repeat to get 34. And one last time, we get the value 34 again. Since we're not using 0 padding, we'll stop at the end of the array. So the result of this convolution is an array with the values 14, 34, and 34. We'll use NumPy to verify again. The 2D convolution operation is defined by this equation. We're going to apply this equation to an image matrix using g equals -1, 1 as our function. Notice that when we apply the kernel, we always invert it first. The following code will perform this operation for us. You can also see a more difficult case here. NumPy is a great tool because it has optimized matrix operations that use a C and C++ backend. But to work with deep learning, NumPy typically isn't enough. TensorFlow performs the same operations, but instead of relying heavily on Python, it creates graphs for the operations and executes them only once with a highly optimized backend. Suppose we have two tensors, a 3x3 filter and a 10x10 image. With 0 padding, the output size will be the same as the input, which is 10x10. This is known as same mode. Without 0 padding, the output size would be the input size minus the kernel dimension plus 1. This is known as valid mode, and in our case, the resulting dimensions are 8x8. You can upload your own images to this window in order to experiment with convolution. A pre-processing step will first convert the image to grayscale. If you want to use a default image, type bird.jpg. We can also experiment with an edge detector kernel. If we start changing the kernel and analyzing the outputs, we'd be doing what a convolutional neural network does automatically. Changing the weights and biases will affect the behavior of the feature maps. It's important to note that a convolutional net typically maps the pixel values into the range from 0 to 1, in a process known as normalization. By now, you should understand how to perform convolution using Python and TensorFlow. Thank you for watching this video. To practice and learn more, go to the lab and run the code for yourself.